Hello everyone. We are now going to work on the second worksheet on the topic of sampling distribution of the sampling mean. Right? So the first question here says a variable of a population has a mean of mu equals 100 and a standard deviation sigma equals 28. So this is just sigma which refers to the population standard deviation. The question says, identify the sampling distribution of the sample mean for a sample size of 49. So what we have to answer here is what the sampling distribution is. Now, we said before that the sampling distribution is either normal or right skewed or left skewed, correct? But when you're answering questions on the sampling distribution, you have to provide two other information as well, which is the mean as well as the standard deviation. All right, so you have to state the mean, you have to state the standard deviation of the sampling mean or of the sample means, as well as the nature of the distribution of the sampling distribution. So let's see how we should be answering this question. All right, now, again, here we are referring to the distribution of the sample mean, not individual observations, individual values of a particular variable, but the sample mean, how the different sample means are distributed for the different sample means out there for all possible samples that could be created from a population. So we learned some rules in this chapter about the mean of the mean of all the sample means and the standard deviation of all the sample means. So let's use those theories that we learned and answer this question. Now, we said previously that the mean of all the sample means, denoted by mu sub x bar, is always equal to the population mean, irrespective of the sample size being used. And the standard deviation of the sample means, the standard deviation is affected by the sample size we use. All right, so it's inversely proportional to the sample size. So the formula for the standard deviation of all sample means is going to be sigma, or the population standard deviation, divided by the square root over the sample size n. All right, so using these formulas, we are going to find the mean of all the sample means and the standard deviation, and then we are going to go on to stating the normal distribution. Now, we said that if we use a large enough sample size, then we can be pretty much sure that the distribution is going to be normal. It's going to be a symmetric distribution, irrespective of no matter how the variable is distributed, right? And the large enough sample size is a sample size greater or equal to 30. So if n is greater or equal to 30, even if the variable is initially not normally distributed, you can assume that it's going to be normally distributed because of its sample size. Anything greater than or equal to 30 implies a sample size which is large enough to make that assumption, right? So let's calculate our means. The mean of all the sample means is equal to population mean. The population mean is given to us as 100. So the mean of all the sample means is going to be 100. What about the standard deviation? The standard deviation of all the sample means is the population standard deviation, which is given to us as 28. So 28 divided by n is 49. So square root over 49, which is 28 over 7. So sigma x sub bar, or the standard deviation of all the sample means, is going to be equal to 4. It's divided by 7, but the standard deviation is going to calculate to a value of 4. Now, how do we phrase this answer? All right. Now, I'm going to take a pause from the recording. I'm going to write out the answer in giving all the information and come back and go over it. All right. So the way we are going to phrase the answer is now up here. It says the sampling distribution of the sample means is normal. So you have to say it's normal first, with a mean or mu sub x bar equals 100 and a standard deviation sigma of x bar, sigma sub x bar equals 4. All right. So this is the correct way of phrasing the answer. All right. Again, you should say mean with mu sub x bar. Do not just write mu equals 100, because the question is about the distribution of the sample means, not the population mean. If you just write mu, then you are referring to the population mean and the population standard deviation. That would be wrong. That would be incorrect. All right. So for this question, please make sure that you write the notation as mu sub x bar and sigma sub x bar. And how did we know it's normal? By looking at the sample size, which is a large sample size of 49. Right, 49 is greater or equal to 30, well, greater than 30. That makes it a large enough sample size to assume that it's going to be a normal distribution. So even though they haven't told us how the variable is distributed, we really don't care if the sample size is large enough. It's going to be a normal distribution. Let's work on the second question now. It says here the times of the finishers in the New York City 10-kilometer run are normally distributed with a mean of 61 minutes and a standard deviation of 9 minutes. For the finishing time, first find the sampling distribution of the sample mean for samples of size 4. So the first question is just asking you to state the sampling distribution relevant to the data given in this problem. So we have to state the sampling distribution of the sample mean with reference or in context of the problem given to us with the mean values and the standard deviation values. Keep in mind that the sampling, whenever you answer a question on sampling distribution, you have to provide 3 components. You have to describe the sampling distribution. I'm going to pull out my pen here. You are going to first describe the sampling distribution. That means whether it's normal or right skewed or left skewed and so on. You will need to also state the mean of all the sample means as well as the standard deviation of all the sample means, right? Now, here it says find the sampling distribution of the sample means for this problem for samples of size 4, all right? Now, to determine whether the sampling distribution is normal or not, we have to either be told that it's normally distributed, the variable is normally distributed, or if that's not given, we have to look at the sample size and determine whether we can assume it's normally distributed or not. All right. So the question here says that the finishing times are normally distributed with a mean of 61 minutes and standard deviation of 9 minutes. So I'm going to write down the data. So it's in front of me. Mu equals 61 minutes and the standard deviation is 9 minutes. That's the population standard deviation that's being given to us, right? And the question already tells us that it's normally distributed. The variable is, all right? So that means we can state that the sampling distribution of the sample means that the distribution of all the sample means of size 4 is also going to be normally distributed. So the way we are going to write it is the sampling distribution is normal with the mean of whatever the population mean is, and then we have to calculate the standard deviation of all sample means using the formula that we had learnt before. All right, so I'm going to write down the answer first and then I'm going to come back and read through it. So here is the final answer saying the sampling distribution of the sample mean is normally distributed with a mean mu sub x bar, that means mean of all the sample means, which is equal to the population mean irrespective of what the sample size is, and that's 61 minutes, and the standard deviation of all sample means denoted by sigma sub x bar. The formula for that is sigma divided by square root over n. So sigma is 9, correct? The population standard deviation is 9 divided by square root over 4, 4 being the sample size given to us. So we come up with a standard deviation of all sample mean value being 4.5 minutes. So this is the thorough way of describing the sampling distribution of the sample mean for any problem. All right, you have to first describe it. What kind of distribution is it, whether it's normally distributed or not, and then you have to state the mean of all the sample means as well as the standard deviation of all the sample means. The next part of the questions is repeat the above for a sample size of 9. Again, same thing, you have to describe the sampling distribution, and we already it refers to the same question, and since the question already said the variable is normally distributed, we can comfortably go and state that the sampling distribution of the sample mean is normally distributed with a mean of 61 minutes. The mean of all the sample means is equal to the population mean, which is 61 minutes. Doesn't matter that the sample size has changed because the mean of all the sample means is not influenced by the sample size. However, the standard deviation of all the sample means is influenced by the sample size. Greater the sample size, smaller is the standard deviation, right? So, greater the sample size, smaller is the sample distribution. I think that's what I said before, but they are inversely proportionate, right? So sigma sub x bar is equal to sigma divided by square root over n is our formula. So 9 divided by square root over 9 is equal to 9 divided by 3. So we get 3 minutes for our standard deviation. Okay. Now part C of the question says, obtain the percentage of all samples of 9 finishers that have mean finishing times within 5 minutes of the population mean finishing time of 61 minutes. Interpret your answer in terms of sampling error. Now it says the uh, it says within 5 minutes of the population mean finishing time. So they're asking us to find the percentage. And remember, from the previous chapter, we had learned that percentage corresponds to area under the curve. Well, percentage corresponds to proportion, and proportion corresponds to area under a normal curve within certain values. It could be less than a certain value, greater than a certain value, or between two values, right? So whenever it says obtain the percentage of all samples, that means they are referring, or you have to go about somehow finding the area under the curve. All right, so obtain the percentage. So again, we will have to follow the process of finding areas under the curve. So what I'm going to do is I'm going to start with drawing a curve. Remember, we always said start with a diagram. That will lead you on to answering the question. All right. So what we do is, let's try to, whatever they're asking here, let's try to picture that here. We have our normal curve, and the normal curve says that the mean is always located at the center point of the bell curve, of the normal standard normal curve, and that's going to be located right at the center. All right, let's just work with a normal curve first. A normal curve will be depicted with actual values, and then we'll convert that to a z-curve, or what's called the standard normal curve. So center point, the mean of 61 is going to be at the center, and the question says they want to know the percentage that of finishers, what percentage of runners had mean finishing times within 5 minutes. Within 5 minutes means plus minus 5. All right, within 5 minutes means it could be 5 minutes over the mean or 5 minutes below the mean. All right, so I'm going to picturize this. 5 minutes above the curve would be 61 plus 5, 66 minutes, right? It would be 66 minutes, and 5 less than or minus 5 would be on the left hand side of the mean, which would be 61 minus 5. So that would be 56 minutes. 56 minutes. So we are going to extend the lines vertically up from 56 and 66. And then we'll have to find this area between these two delimiting values. And then once we find the area, we can convert that to percentage, right? However, we will need to refer to the table, but the table doesn't work with actual values. The Z table, the standard normal curve table, works only with Z values. Therefore, we have to convert 56 and 66 to Z values, the corresponding Z values. So there are two values here. We'll have to find Z sub 1 and Z sub 2. Okay, so Z sub 1, if Z sub 1 is, or X sub 1 is 56, right? Here, let's say the mu equals 61. And this is a follow-up question from the previous problem, right? So mean is 61, but the standard deviation, how much was the standard deviation? The standard deviation was 9, and the sample size that we must use is 9, correct? So n is going to be 9. And the formula that we are going to use this time to find the Z values is not Z equals X minus mu divided by sigma. This cannot be used because we are not working with individual values of a particular race. No, we are working with the sample means. It says obtain the percentage of all samples of 9 finishers, right? So we are now working with the sample means. Our individual values are sample means. So the formula is going to change slightly. It's going to be z equals, again, it's not x, but we are working with sample means. Therefore, x bar minus mu over, you have to use the standard deviation formula for the mean of all sample means, which is sigma divided by square root over n. That's going to be our formula that we are going to use for this problem to calculate the z values. All right. So x bar is 56 is the first x bar sub 1, and let's make 66 x bar sub 2. All right. So we will end up with x bar 56 minus 61 divided by sigma over square root over n. So 9 divided by square root over n. So it's going to be minus 5 over 9 divided by square root is 3, right? So we already calculated that up above. So that's going to give us a value of negative 1.67. And for z sub 2, it's going to be 66 minus 61 divided by 9 over square root over 9, which is 5 over 3, which is positive 1.67. Okay, so now you have to go to your table and find the corresponding areas. All right, so I'm going to just do this here. Area of negative 1.67. So I'm going to draw a standard normal curve here and represent my z values that I just found. All right, so now it's a standard normal curve. The center point is going to be a 0 because the mean is always located, mean has a z-score of 0. And then on one side, it's going to be negative 1.67. On the other side, it's going to be positive 1.67. 1.67, and we are looking for this area in between these two z values, right? So first we can find the area corresponding to 1.67. Remember, I told you that start with when we have to find area between two z values, start with the area of the higher z value. So area corresponding to 1.67. Again, you can check this on the table. I'm not going to bring up the table now, but the area is 0.9525. That's the area to the left. So all this area is 0.9525. But we do not need the area outside this bounded region, correct? We have to subtract the area to the left of negative 1.67. You have to subtract this area. So for that, find area of negative 1 corresponding to negative 1.67, and that should be a value of 0.0475, and subtract that value, all right, that outside value, and you should come up with a value of 0.9050. So that would give us a percentage value of 90.5. All right, so you're going to interpret it saying, I'm going to write the interpretation and come back and read through it. So you're going to phrase it as 90.50% because the question asked you to find the percentage of all samples of 9 finishes. So 90.50% of all samples of size. You do have to state the size in your interpretation because this area would have been different if we used a different sample size. So 90.50% of all samples of size 9 had mean finishing times. Mean finishing times. You can just take the wording from the question. Finishing times. Let's go back to the question because that's probably easier. Within 5 minutes, right? Have mean finishing times within 5 minutes of the population mean finishing time of 61 minutes. You can just verbatim copy this verbiage here within up to this point. So mean finishing times within 5 minutes of the population mean finishing time of 61 minutes, right? Time of 61 minutes. So that's how you're going to go about answering this question. You are going to use the same steps that you used in the previous chapter to find areas for under the curve for certain values, certain observations. But here, the only difference is here we are using a different formula for the z values because we are not working with individual observations. Our observations are really sample means. All right. So whenever you are working with sample means, the formula of the z value changes slightly. Okay. So we'll do a similar question again below here. So we'll work through that question, which will give us a little more practice. All right. We are now going to go through this last problem in this worksheet. This problem is pretty important because you're going to get a similar problem on the test. So just make sure you understand how to work this problem and get it right. Now the question says in 2005, the mean retail price of all history books was $78.01. Assume that the standard deviation of this year's retail price of all history books is $7.61. If this year's mean retail price is the same as the 2005 mean, what percentage of all samples of size 40 of this year's history books have mean retail prices of at least $81.44? State any assumptions. All right. So yeah, that was a mouthful, but let's just ask ourselves, what are they asking here? So I'm going to go back and just read through the last part of this question, and then I'm going to go back and I have to dissect this question further. But the first thing that I must know is, what am I supposed to do? What am I supposed to provide them as an answer? It says here, what percentage of all samples of size 40 of this year's history books have mean retail prices of at least $81.44? So the key word that tells us what I'm supposed to do is this word percentage. Percentage should immediately tell you that we have to find an area under the curve in this case. All right. So in order to find the percentage, if we can find the area under the curve less than or greater than or between two values, whatever the question may be about, then we can just convert that area into percentage and come up with the answer. And area immediately tells us that we need to look into a table for the area, right? And it is the area under a standard normal curve rather. All right. So given that, let me just list what we are trying to deal with here. We have to provide them the percentage, and in order to provide them the percentage, we will need to know the area. To find the area from a table, we need to find z values, right? We need to find z values, and then we have to, how do we find the z values? From our, using the formula, of course, but we need to know what the sample mean is, what the population mean is. We need to know what the standard deviation is, what the sample size is, and so on, right? That's what is involved in the z-value formula. So that much information we have been able to obtain from just this word here which says percentage. What percentage? So now we know what the question is about. Now, we have to now, in the second step, we have to extract the data, right? So I'm going to again read through this question sentence by sentence. It says, in 2005, the mean retail price of all history books tells you that this mean price is the population mean, all right? All history books in this particular year. So that was $78.01. So I'm going to write mu equals 78.01, right? So we know our mean now. It says, assume that the standard deviation of this year's retail price of all history books is 761. So now I know the population standard deviation, which is $7.61. We have to then find X bar. So if it says here, if this year's mean retail price is the same as that of 2005, so that's an assumption, what percentage of all samples of size 40 of this year's history books have mean retail price of at least $81.44? Now, one word that is getting repeated over and over and over again is the mean. All right. So that means we will be dealing with sample means here. And they've also given us a sample size. So that means n, samples of size 40 means n equals 40. And here we are dealing with sample mean. So that word mean occurs over and over again in this question, right? So we are not talking about values of a particular variable, but we are talking about the sample means. All right, so we're going to say X bar is, now it's not just 81.44, it says at least 81.44. All right, so at least means, what does at least mean? All right, let's just write it down on the side. At least means 81.44 is the lowest value. It could be something higher than that, but it should not go lower than 81.44. So that means at least 81.44 means X bar is greater or equal to 81.44. That's what at least means. That means 81.44 is the lowest value. So we start from 81.44 and it can go up, but it cannot go below 81.44. So that means X bar, we are trying to find what percentage is at least or has mean retail price at least 81.44. That means 81.44 or higher, right? Now, given this information, what I'm going to do in the next step is to draw my curve, the normal curve, using these values. So first I'm going to just draw this curve here. Again, a normal curve is a symmetric bell-shaped curve. and at the center of it will be the population mean. So 78.01, that's the population mean. And then when it says X bar greater or equal to 81.44, that means 81.44 is higher than 78.01, so it will be situated somewhere to the right of 78.01, the population mean. So that's going to be an X bar value of 81.44. Now, given that, and that we are talking about at least, what does that mean? What is our region of interest? Our region of interest is everything, the area to the right of 81.44, right? At least, that means greater or equal to 81.44. So our region of interest is this area, region of interest. All right. Let's color this. This is our region of interest. Now, given that we have now shown our normal curve with the actual values, we now have to find the z values, because we have to go to a table to find the area. However, our table, if you recall, our z table does not work with actual values. It only works with z values. So we have to calculate the z with reference to the mean of 78.01, the X bar value 81.44, and the standard deviation value given to us, as well as n. So because we are dealing with the mean of all the sample means, we are working with sample means here, we have to use a slightly different formula for the z value, and that's going to be z equals X bar. So instead of x minus mu, we have to write X bar minus mu over, for the standard deviation, it's going to be the population standard deviation divided by square root over n. Remember, this is the formula we learned for the standard deviation of all sample means. So we have all our values. So X bar is 81.44, so 81.44 minus mu is 78.01 divided by 7.61 is the standard deviation, the population standard deviation, divided by square root over 40. That's our sample mean, right? Sorry, that's our sample size, excuse me, not sample mean. The sample size n is 40. So when you do this calculation, we should come up with a z value of 2.85. So in the same diagram, I'm going to now show the z values corresponding to mu, the population mean at the center will have a z value of 0, and this point, all right, on the right hand side corresponding to 81.44 is going to be the z value that we just found here, that's 2.85. So now that we have our z value, we are ready to go to our table, the z table, and find the area. Now, I'm going to take a pause and I'm going to first pull up the table, and then we are going to continue with finding the area, because I just want to show you the process of finding the area one more time using the table. So now, before we go to the table, we have to remember that we are interested in the area to the right of the z value 2.85. So I'm going to write here, all right, find area to the right of z equals 2.85. Just a second. 2.85. So now I'm going to go to the table. All right, and here's our table. Remember, the Z table always gives the area to the left of a certain value. So if Z is, let's say this Z value here is 2.85, all right, then the area that you find from this table is going to be the area to the left of whatever Z value we want to look up. All right, now to find the area to the right, all we need to do is subtract the area we find from 1, because the total area under the curve is going to be 1, correct? Is always 1. So if we know this much of the area to the left, then to find the area to the other side, to the right of that value, just do 1 minus whatever area you found for the left side. All right, so our Z value is 2.85. This is the positive Z value table. So go down to up to 2.8. So let me pull up the pen here. All right, so 2.8 is located here. So now I'm going to, so 2.8 is here, and 0.5, so 0.05, the second decimal is here, right? So it goes like 2, 0, 1, 2, 3, 4, 5. All right, so I got the place, although it's not visible here. Let me see if I can zoom it in a little bit, or zoom it out a little bit. Okay, no problem, it's way down here, so we'll just go along without wasting time. So 2.8 is here. All right, so you first have to come down the first column of the Z value. So 2.8, stop here, and then for the second decimal place, which is 5, let's see, we start with 0, 1, 2, 3, 4, 5. So the corresponding area for 2.85 is 0.9978. This is the value, but this is area to the left. All right, so now I'm going to go back to my worksheet here, 0.9978. All right, so the area to the left, all right, I'm going to write here from the table, from the Z table, area to left of 2.85 is 0.9978. All right, therefore area to the right, is going to be 1 minus the area to the left, which is 0.9978. So we get a value of a very small value, 0.0022. All right, so that's the area to the right. So that means this area here is, 0.0022, and all this area to the left is what we found from our table. That was 0.9978. 0, just a second, it's 0.9978. All right, you get the picture. Sorry, it's a little bit clumsy. All right, so now this is the area to the right, but the question said what percentage. So we have to convert this to percentage. How do we convert this to percentage? Multiply it by 100. So it's going to be a very small percentage. The way we interpret or write the final answer is that, let me take out the blue pen here. So interpret in context of the question, 0.0022 multiplied by 100 is 0.22%. It's not 22%. It's 0.22%. All right, so let's go ahead and write that 0.22% of all sample sizes, and I'm pretty much going to copy the verbiage from the question. All right, do not think too hard, just go to your back to your question and pick up the verbiage, pick up the wording from there and write it as is. All right, not a problem there. So 0.22% of all samples of size 40 of this year's history books have mean retail prices of at least $81.44. That's all, right? So 0.22% of all sample sizes of 40 of this year's history books will have a mean retail price of $81.44 or more. All right, and then they asked one other question, state any assumptions. Now, even though it didn't say anywhere in the question that this was a normal distribution, because the sample size is 40, which is considered a pretty large sample size. The sample size is large if it is greater or equal to 30, and 40 is definitely greater than 30. So by that measure, we can pretty safely assume that it's going to be a normal distribution. All right, so you may have to state that if they ask you, state any assumptions. So you can say no assumptions on distributions. No assumptions on distributions had to be made. Why? Because the sample size is large enough. Distributions had to be made as the sample size n, as the sample size of 40 is large enough, right? Is large enough to make the distribution normal. To make the distribution normal. All right, so that should complete your answer. Again, as I said before, this is an important question. You may get a question similar to this on the test, so make sure you understand how to work through it. Maybe you can just practice a few problems. There should be a similar problem on the review, test review project sheet as well. All right, so that completes the worksheet for this entire chapter on the sampling distribution of the sample means.